Exercise 6 says an ice cream mix having a viscosity of 70 centipoise and a density of 10-15 kg per meter cube is being canned aseptically in a system which uses a 100 feet long 1-inch sanitary pipe for a holding tube. The flow rate through the system is 5 gallons per minute. The fluid temperature at the exit from the holding tube is 285 degrees Fahrenheit. First, we are going to calculate the residence time for the fastest flowing particle, and then the d value of the process given d0 1.83 minutes and z equals 24 degrees Fahrenheit. Now the residence time for the fastest flowing particle, so I have to look at the following equation, which is related to the velocity of the fastest flowing particle, and as v equals L over time. Okay, L is the length where the particle is transmitting through, time is the time of the fastest flowing particle, and V, I want to calculate it V maximum, which is the velocity of the fastest traveling particle. How can I get the V maximum? V maximum is equal to 2 times the V average, okay? And I can get out the V average from the flow rate because Q equals V times A. And the flow rate is given to us 5 gallons per minute. So it would be the flow rate over the area. Great. The 5 gallons per minute, I'm going to transmit it to the SI unit, which is meter cube, by multiplying it by 3.78541 times 10 to the power minus 3, and the minute into seconds. Now I got this out from the internet. And divided by the area, which is pi r square. How did I get out the pi or the r? From the d, and the d I get it from the table for the dimensions of 1-inch sanitary pipe, which is table 5.2 in the previous chapter, and the r would be 0.01146 meter, dividing this by 2, and هيدي أكيد رح تكون to the power square. The V average would be at the end 0.765 meter per second. What will be the V maximum? V maximum is V average multiplied by 2. So it is 2V, 2 times 0.765. It's equal to 1.57 meter per second. Can I get now the T? Yes, easily, because the residence time of the fastest flowing particle would be equal to the length that I've got, which is 100 feet, over the V maximum. Now 100 feet, again I will transmit it or transform it into meter, and it's equal to 30.48 over 1.57. The residence time of the fastest particle would be 19.41 seconds. Perfect. For the next part, which is calculating the d value of the process at d0 equals 1.83 minutes and z equals 24 degrees Fahrenheit, I'm going to use the following equation, which is log d over d0 equals d0 minus t over z. I want to find out the d at the respective temperature, which is 285, and we said before that d0 for the sterilization, it would be how much as a reference? 250 from the previous exercise of 5. And in case of pasteurization, we will take it as 86 degrees Celsius, as I remember. And then divided by Z, it would be 24 degrees Fahrenheit. Make sure that all are in Fahrenheit over here. So if I use the reference in degrees Celsius, I will transform this one to degrees and this one to degrees. And if I use it in Fahrenheit, the other temperatures must also be in Fahrenheit. Log d over d0, this factor would be equal to minus 1.46. So d is equal to d0, 10 to the power minus 1.46, and the d0 as in given 1.83 minutes, so the final answer would be 0.063 minutes and corresponding to 3.81 seconds. By this, we have finished the exercises of the chapters. As for the chapter of the food freezing, we did the exercise together in class, and in case any exercises were missed, please, and you need to know the answers for them, send me your answers or your solutions on the group on WhatsApp. I will check them and I will refer if they are correct or not. Any questions, also please feel free to ask me. Thank you so much and best of luck in your finals.